Now let's see this question. How many 3-state DFAs can be constructed with a designated initial state over the alphabet A comma B? Now if we have 3 states, let's say the 3 states are X, Y, Z, and now they are saying that designated initial state is there, which means one state is already fixed as initial state and the alphabet is A comma B. Now they are asking us how many such DFAs are possible here, right? So now see this. First we had to decide upon how many such structures we get, right? Once we get these structures, for each structure how many DFAs we get, right? So structures means I am talking about the final states. Since it is already given that one of the state has to be initial state, I don't have any choice in changing the initial state to either Y or Z, right? So initial state should always be fixed as Y. Now coming to final state, I can have one final state and that final state can be either this one or this one or this one, or I can have two final states like this. Okay, so let's see all the cases possible. Coming to the final states, I can have out of X, Y, Z, X as the final state or Y as the final state or Z as the final state, right? Or I can have zero final states as well, right? Which means X, Y, Z, nothing is a final state. So zero final states, I have one such possibility. One final state, I have three such possibilities, and two final states, right? Which means these two can be final states, or these two can be final states, or these two can be final states, right? Which means three possibilities, or all of them can be final states, isn't it? Which means all these three can be final states. Only one possibility I have. Now coming to each possibility, when you put them in a structure like this, for example, this structure is representing this possibility where X and Y, X, Y, Z, none of them are final states. Coming to each possibility, here I can have two ways of filling it. I can either fill it with X or Y, right? X or Y. Now 2, 2, 2, 2, 2, 2, right? So how many is this? 2 power 6, isn't it? Which is 64. So for every possibility I have 64, right? 2 into 2 into 2 into 2, 4, 2 into, oh, actually 3 states are there, right? So 3, 3, 3, 3, 3, 3. So it is 3 power 6, right? So this is 3 power 6. Okay, and now how many such possibilities are there? 3 plus 3 is 6, 6 plus 2 is 8. Therefore 8 into 3 power 6 is the answer. Got it? Okay, so this is the way you can solve it, given that there are only 3. But then let's see what if they have given that 100 states are there, or let's try to generalize it to some other number. Okay.